So here we're given an f of x, and we want to find f of 3. We're first going to do it by what we call direct substitution. This is what you call plugging it in. Mathematicians call it direct substitution, because you directly substitute 3 for x. Okay? So here we're going to have 3 times 3 cubed minus 6 times 9 plus 3 minus 11. And at the end of the day, f of 3 ends up being what? 19. Okay, f of 3 is 19. Now, we're going to do the same thing by long division. We're going to find f of 3 by long division. Okay? Well, how do we do that? If my value a is 3, all right, then I have a factor x minus a, which is x minus 3, right? And that becomes my dividend. All right? So this is what I'm finding f at a value of a equals 3. And I just do x minus that value, and I get x minus 3. And this is my dividend with a d, not a t. All right. So now I have x minus 3. And here I have 3x cubed minus 6x squared plus x minus 11. All right. So remember, x minus 3 is my x minus a, right? In fact, let me write that in a different color. Okay? Now, let's divide this. So first it's going to be 3x cubed over x. That gives me 3x squared. I multiply, I get 3x cubed minus 9x squared. Now I'm going to subtract. So I have 3x squared plus x. All right, what's the next term in the quotient? 3x, positive 3x. So that gives me 3x squared minus 9x. I'm going to subtract. All right, so what does that give me? 10x minus 11, right? And the next part of the quotient, plus 10. So I have 10x minus 30, and I'm going to subtract. And what do I have left over?
19.
Oh my gosh.
Wow.
What's 19?
19 is the answer.
19 is f of 3, right? F of 3 equals 19. It's the remainder. Okay?
My brain. Wow.
Okay? Now, let's do the same thing by synthetic substitution. So basically, I'm going to put that same value of a, which is 3 here. And in here, I have my 3 and my negative 6 and my 1 and my negative 11. So 3 comes down. I have 9, 3, 9, 10, right? And what do I have here? 30, 19. That's my remainder. So f of 3 is equal to 19. Okay? 3 different ways. We get 19 for all of them. So what do we notice? That when we divide, whether it's by long division or synthetic division, all right, the value of my function at that point A is just the remainder. All right? And now we're going to do the proof of this, and you're going to see why it's always going to be the remainder. All right, so let's look at a proof of this. All right? Now, if I were to divide any old number, all right, so suppose I were to divide 61 by 4. Okay? What would that look like? 4 goes into 61 how many times? 15. And let me write that in red. And that's my 4 that I had before. I just want to be consistent with the colors. So 15 times 4 is 60, and that's a remainder of 1, right? Now, can I write this as, so can I say that 61 then, okay, is equal to 4 times 15 plus what? Plus 1? I could say that, right? So 61, all right, is equal to the 4. What's the 4? I'm sorry, this is the divisor. This is the dividend. So my dividend is equal to the divisor times, what's the 15 called? The quotient plus the remainder. Is that right? Okay, now let's write the same thing here. So the dividend is equal to the divisor times the quotient plus the remainder. All right, so what's our dividend here? It's 3x cubed minus 6x squared plus x minus 11. That's equal to, what was the divisor? X minus 3 times the quotient plus the remainder. Now, what's another word for, okay, so the dividend, that was the function that I started with, right? At the very beginning, is that called f of x? Yeah, that's called f of x in the very beginning, right? So I can substitute f of x for this, yes? So f of x is equal to x minus 3, 3x squared plus 3x plus 10 plus 19. This in the beginning, in the very beginning of the page, this was my f of x, all right? Now, remember how I also said in the very beginning when I needed to find f of 3, I said, you know what, that 3 is like your a value, and I said x minus 3 is really, you know, like we could just call it x minus a, right? So suppose now I want to find f of a, right? Not just f of 3, but just f of a, f of any old number, okay? Well, that's going to equal to what? A minus a, right? It's a minus a because, well, okay, let me add in one more step. F of x is x minus a times, I don't want to write this all over again. I'm just going to call it the quotient, all right, plus 19. All right. Now, what is f of a? F of A is A minus A times the quotient plus 19, which is the remainder. Let me just call that the remainder. Now, what's A minus A? 0. So what's F of A always gonna be? The remainder. Okay? Alrighty? So that's the proof. So no matter what, okay, F of A is always gonna be the remainder. Okay, now let's talk about the factor theorem. When a polynomial division produces a remainder of 0, all right, we say that the divisor is a factor. So when you divide, when you do any division, right? So before we did 61 divided by 4. Now let's do 60 divided by 4. How much would it be? 15. And what would the remainder be? 0. Why? Because 15 is a what of 60? It's a factor of 60. So when I do any polynomial long division or any polynomial synthetic division and I get a remainder of 0, that means I've just divided by the factor. Okay? And the quotient in that case is called a depressed polynomial. Yes, it's funny. Okay? It's called a depressed polynomial. All right, so look at this question. It says determine if x minus 3 is a factor of this. If it is, identify the depressed polynomial, find the other factors, and then graph. So let's just go ahead and do that. Can I use synthetic division for this? I can. So it's going to be 3 here. And 1, 4, negative 15, negative 18. It's positive 3 because we set it equal to 0 and get the 3. All right, so here we have 1, 3, 7, 21, 6, 18, 0. Okay, what does it mean that the remainder is 0? So yes, x minus 3 is a factor. Yes, you can. All right, so what does that mean? Okay, that means f of x is equal to, right? What were we doing before? F of x is equal to the divisor times the quotient plus the remainder. So x minus 3 times the quotient. Okay, so how do we get the depressed polynomial out of this? X squared plus 7x plus 6. All right, so that's what f of x equals to now. All right, I just factored it. Could you have factored that polynomial without any of this? No, but look at this. Now we can factor. Now, can we factor this further? Right, this is x plus 6, x plus 1, right? So what are the zeros? X equals 3, negative 6, and negative 1. So at x equals 3, at x equals negative 1, and at x equals negative 6, there is a 0. Okay? Now, can we graph this? How would we graph this? Yes. One more time. The leading term is x cubed. The degree is 3, which is odd. That means one side will be up, one side will be down. Because the leading coefficient is positive, it'll be up on the right side and down on the left side. All right? So it'll be up here and down here. And the rest, we're going to do a sketch. So can we find the y-intercept here to give us a better idea? At the y-intercept, what's x? 0. So the y-intercept is 0, comma, negative 18, right? So 0, comma, negative 18. So my graph will come down here. And it's going to go all the way down because it's going to hit negative 18 down there, which we're not going to be able to see. So let me just redo this. I'll call this negative 10 and this negative 20. So negative 18 is here. It's going to hit this, come up somewhere. Now, somewhere here, it's going to go back down and like that. Okay, now, how high it goes up, that doesn't have to be exact as long as you have the general form. Okay? All right, here's another one. We have a polynomial and one of its factors. Find the remaining factors. So what are we going to do? We're going to divide. We can divide using synthetic division. So we have 1, negative 6, 11, negative 6. 1 comes down, negative 5, 6, and 0. What happens if you don't get a 0 there and you know that it's supposed to be a factor? Then you made a mistake somewhere, so you have to go back and check. All right? So f of x is equal to x minus 1 times what? X squared minus 5x plus 6. So f of x is equal to x minus 1, x minus 3, x minus 2. So what are the zeros? 1, 3, and 2. 1, 2, and 3. All right. Now, again, is the leading term, is the degree odd or even? Odd, so one side up, one side down. Positive leading coefficient, so right side up again. So it's going to have the general form. Do we have a y-intercept for this? Y-intercept is 0 and negative 6. So it's going to come up and back down and back up and go up indefinitely. Again, how high you make the peaks and how low you make the valleys, I'm okay with the general form. It doesn't have to be specific. But I do want to see that you have a maximum between 1 and 2 and a minimum between 2 and 3. Okay? Questions?